All right, so as you said, I'm Ryan Sullivan. I'm a production engineer for WR Grace in our Magnapur facility, and I think we've heard through this conference how the chemical industry itself is kind of lagging on this IT-OT convergence. And so I'm going to talk a little bit how we've been using Capstone Technologies' dataPARC suite to actually catalyze that, not just within our facility, but within Grace as a company. Just a little bit about Grace. That's a nice little overview of what our facility looks like. Grace is a $2 billion technology leader in specialty chemicals, primarily focusing on refining technologies, specialty catalysts, and materials technologies. 80% of our business is in fluid cracking catalysts and hydroprocessing catalysts. And then my site in particular actually offers both the analytical and manufacturing services for Grace as a company. We are the largest Grace facility. We're located in just across the bay in Curtis Bay, Maryland from Baltimore. We occupy about 1 million square feet as a facility, having multiple plants within that facility. And we do have about 600 people itself. The plant itself actually opened in 1909 as Davison Chemical Company, so you can get an idea of how our legacy systems are going to be pretty old. But I'm not here to talk about Grace. I'm here to talk about how we've been doing IT-OT convergence. And to understand where we are, I kind of have to understand where we started. We had a really robust OT system, but we didn't really have any way to analyze it. I found myself when I was first brought on, before we had Capstone, that it was easier to go through our HMI system than it was to actually use the software that we had. The software we had was simple, minimal manipulation, and that was about it. It wasn't very intuitive, so there was no buy-in from anyone. Only engineering was using it. No operators, no managers, and so you kind of limit your data if only one person's looking at it. And then on top of that, we had all of these IT systems like our eQual database where operators would online input field samples, our GLIMS database for all of our lab information, and then SAP itself. So, and on top of that, we actually only had 5 licenses for that software. So only 5 people can use it, and WR Grace's largest facility, you can see that becomes a bit of an issue. And what we found at the end of the day is when we looked at it, that we had our IT world and our OT world that were completely disconnected, and there was just no communication between them whatsoever. And that's obviously a problem. So when we brought in Capstone, there was a lot of things that we actually focused on. And this is a nice little snippet of what we looked at. Performance was obviously a big concern. We have real-time data that we need as a production facility, so it had to be fast and reliable. From a reliability standpoint, we actually had to be able to pull not just the instantaneous data, but we had to be able to look back over several years in case we had to do any troubleshooting. Its compatibility was incredibly important for us, making sure that not only it worked with our current systems, but if we wanted to add any systems in the future, it needed to be able to mold with us in that case as well. Its scalability, the ability to actually move across the company, not just within our facility. I think right now we're operating at about 6 sites for WR Grace right now, with it growing. Worms is in development. We wanted advanced modeling as well. We wanted to be able to create models of what an ideal process looked like, so we could actually see in real time if the process is deviating, and that allowed us to actually do more predictive asset failure rates. We also wanted more complex process and analytics, the ability to create custom information if we don't have it already. Maybe the slope change of a silo filling was important to us. The ability to create that information based on information we already had was incredibly important. And it was also opportunities. We wanted to make sure that we wanted to see a reduction in plant downtime and a reduction in cost of poor quality, and thus an increase in first pass quality of our actual products. And then mobile communication was incredibly important to us, to actually have that data on the go with us instead of having to come in Monday morning and find out, everything fell apart. And so at the end of the day, when we implemented the dataPARC suite, we found that our IT world and our OT world, the clicker once works, actually came together and without having to rip out any of our current systems and replace anything. And so what we focused on when we implemented dataPARC was having one user interface, not having to go out and seek information, the ability to actually improve our asset performance, and overall have a better, man, this clicker's killing me, efficient operations within our process. So some of the things that we started doing with dataPARC is generating reports of how our information's actually coming in. We were actually able to see if process upsets were real instead of if it was, a gut check of it looks like it's failing, but is it really? And so what it allowed us to do is it actually allowed us to update our preventative maintenance plans to actually reflect real asset failure rates rather than running it for 10 days when it's actually, should have been done 10 days ago. And a good example of that is a bag house that we actually use in one of our processes. So we created an alarm system where if that bag house was operating outside of a certain limit for an extended period of time, we'd actually get an alarm to go in and look at it. And that was just where we started. And so what we found is when we got that instant alarm notification via email, phone, like I said, having that data on the go, is we started to look at the actual trend. And what we found, and this is a nice little snippet of it, you can see in the red, see if this laser works. You can see in the red right there, that's about a 7-day shot of when the bag house is actually operating outside of its normal operating limits. And we found that the bag house actually had a failure rate of about 28 days that we didn't actually know. So what we did is we went in, we created a preventive maintenance plan that reflected a 28-day shutdown of that bag house and allowed us to switch over. We also started generating weekly reports of the actual bag house. So that's what it looks like when it's out of control. We're seeing vacuum on our equipment varying from -3 to 3. And for a bag house, you want a nice consistent DP across that bag house. And so after we implemented this plan, we started generating another weekly reports, and that's what we actually see every Friday in our quality meeting. A nice consistent vacuum across the bag house. And if it starts to deviate from that, we can actually go in and know, oh, hey, our bag house is failing. We need to work on it. Another thing that we started to do is actually having our quality management system on the go with us. So we had a big issue in 2017 where we would create bad product on the weekends, but because we're a 24/7 sold out manufacturing facility, we wouldn't discover it until Monday morning. And there's nothing you can do about it once the product's in the drum. So our first pass quality was taking a massive hit. And this is a nice little snippet of our OT information, all of our silo trends on the top there, integrating with our GLIMS database down on the bottom there. And you can see some of the shots where one of the specifications is actually, oh, there we go. You can see where the material is actually falling out of spec. So I'll actually get an alarm notification if any of this happens. And that's what it looks like. And so I get an email notification, a text notification. I actually get a link to the exact trend so I don't have to go out and find the data. It comes right to me. And so this has actually improved our first pass quality because now I can notify our foreman if we need to change our blending protocol during the weekend rather than come in on Monday and found it. And it actually translates to actual savings because what we found in 2017 from this exact issue is we did $280,000 in cost of poor quality of our material. That number dropped to $52,000 just for this issue. So that's a significant chunk of savings that we've actually seen. It's real money in Grace's pocket. Another thing that we wanted was a simple user interface, a dashboard that not just operations could use, but anywhere up to management as well. And this is a dashboard that we have in the control room for operators and our plant manager looks at every morning. And so what this allows them to do is get critical information for the process fed to them and they can tell if it's instantaneously out of range or not. And you can see in the bottom right there that the final pH in this process actually isn't in spec in this instance. In addition to that, because all that information comes to one user interface, it can start to drill down specific information just from this page. Like they can look at the raw material information and make sure that all of the tanks are actually in their normal operating mode. And if that's not it, they can actually pull in our quality database, which is a completely different IT system, and see, well, is the process just out of control for this one instance, or has it been out of control for a while? Is it a known issue that we haven't really drilled down? And then on top of that, we talked a little bit how the operators have an online field entering information. They can pull that up as well. And you can see on the right-hand side there that the pH in this case had actually been out of spec for a long period of time, and it was likely a known issue. But it's having one centralized, simple user interface that, like I said, anyone from operations to engineering to managers can actually use. Yeah, so I have a little video for you guys, and a little concept on this video is, like I said, we wanted process modeling, the ability to create models of our process and see in real time if they deviate. Important thing to note about this video that you're about to see is that's actually about real time for creating models of our process. It only takes, it's a quick click away with the dataPARC software system, and it's been an invaluable tool for determining, troubleshooting actual, in particular, steam outages in our plant.
modeling of our process, what we need to do is actually start with one of our processes. And that's exactly this trend that you see here, one of our batch dryers. So what we're going to do is we're actually going to pull the 10 fastest runs out of the last 25 that have actually gone through this. So what we do is we actually open up our run browser, we select the 10 fastest runs after filtering everything, which is what you see here, and we're going to load these into this trend. And what you're going to see is a nice overlay of the 10 fastest runs out of 25. And this is great to look at and compare how things run against each other, but like I said, we're looking for a statistical representation. So what we're going to do is we're actually then going to select the 10 here right here and open the actual PARC model software. And this is what we're going to generate, a nice modeling system. Now we can see here that we have an R-squared value of about 0.74. It's not the greatest, but for the sake of this trial, that's what we're going to go with. Now I have it set as the output to be the BPEX timer, which is what we're shooting for since we're aiming for the shortest, fastest runs. And from this PARC model, we'll actually generate the models of a DMOD X trend and a Hotel NT squared trend. Now in this case, it looks like the Hotel NT squared trend seems to be the best, with most of its value not hitting the upper limits according to the model. And so when we generate that trend, this is what we're going to get. The top one there is going to be the DMOD X. The middle one's going to be the Hotel NT squared, and then the bottom one's going to be a modeling system against the actual BPEX timer. So from here, we're actually going to open up a contribution plot. And because I said the Hotel NT squared seemed to look the best, that's what we're going to go with. And we can already see right now that the thing contributing to the shortest possible batch times is actually our zone 1 temperature. And we're actually going to click on that bar, and it's going to open up the contribution plot for the zone 1 model, which is exactly what you see here. Now from here, what we can actually do is we can take the model that it generated and we can overlay it with the rest of the process. And what we do when we have that and we reintroduce this into our original trend is we get a nice comparison of how zone 1 is running versus how it should be running. And you can see there in the middle, you'll have red bars indicating that the process has started to deviate from its predicted ideal run. That allows us to go in and troubleshoot and actually assign reasons which we can use for downtime Pareto chart management later down the line.
But yeah, so that's the modeling system they used. And in the case of those two red bars, it's actually because that process was running longer than what the model said it should be running. So we can already tell that something was wrong. So when we get down to brass tacks, we want to see some of the benefits and performance metrics that we've actually seen by doing an IT-OT convergence with the dataPARC system. And what we found is that we started from nothing and we're on that path. It's a long path and we haven't quite gotten there yet, but we're making that progression, not just at my facility, but as Grace as a whole. And it's improving everything. The ability to actually have all of our user interfaces all in one place means that instead of having to go out and find information and having lab people only using the lab database and engineering only using the process information, it's all come together. It's all available to operations, engineering, and managers. And we actually moving to the actual IT-OT convergence generated savings in 2017 of $42,000 in and of itself. The dataPARC system is a convenient and frictionless interface. It's easy to use, it's intuitive, and we're getting operator buy-in because of it. And I think that what that's contributing to is an engaged employee within the process. And it's increased learning. I think we all realize that there's a bit of a knowledge offset in the chemical industry. And having this kind of system where everyone's engaged actually decreases that knowledge gap and allows employees to become more familiar with the software faster. So moving forward, some of the site-wide ambitions and projects that we have going on. Wants to load. So some of the site-wide ambitions and projects we have going on, we're obviously always pushing for site-wide buy-in. The more people that are on the IT-OT convergence path means that we're going to have better communication between operations, engineering, and management. We're seeing an increased knowledge of the system. The more people that understand the IT-OT convergence path means that we're going to get there faster. We're getting early warnings and root cause analysis systems more fine-tuned to what's actually happening. So some of the current projects that we're working on right now, we're doing critical to quality analysis systems for the site-wide for every single plant. Essentially, we're going to have the ability for everyone to see when the plant is operating outside of its normal limits, and as well as its runtime. So operations can actually look in and see if they're deviating from their normal operation in a quick user display like you saw earlier. And when you get down to it, you have to ask, how is this IT-OT convergence path helping Grace? And the simple answer is that it's improving our customer quality product. It's increasing the ability for our processes to run more efficiently, and it's keeping employees engaged with the actual process so they understand what's going on. And it's really pushing for an enterprise-wide integration. It's not just a local thing. It's a thing that can encompass the entire Grace system. And that's all I have. Grace is on a path to full convergence, and it's a long road ahead of us. But with Capstone's dataPARC system, I think we're getting there faster than we would have if we'd just done it by ourselves.